Hi there, and welcome to another episode of Your Old Anatomy Professor. I'm Becky Edmiston, your old anatomy professor. So, you're getting into studying cancer, which is a really interesting topic that I think most of us know someone who has or has had cancer. And so I think you're going to enjoy learning about this. Really, the only things I have to review with you come more from Gen Bio than anatomy physiology. And so the thing to keep in mind with cancer is the root of all cancer is a DNA mutation, a mutation that has taken place altering some genes. Now, keep in mind these mutations could be inherited, but these mutations can also be spontaneous, meaning they happen somewhere during the cell cycle. They didn't get passed on from parents. And there's also mutations that are induced. They're triggered by environmental causes. And so that's important to keep in mind as well. Now, the genes that are going to lead to cancer, this uncontrolled cell growth, really we're talking about two sets of genes. The first are what are called proto-oncogenes. The proto-oncogenes are what tells a cell to divide, right? It encourages that cell to go through mitosis. So if you remember our cell cycle, right? Remember that very small portion of the cycle is actually mitosis, is actually division, but a cell spends the majority of its time in what's called interphase. Now, I think in Gen Bio we tend to focus in on mitosis, but as you start to think about cancer, this is what becomes important. There are basically checkpoints in the cell cycle, right? So here we see this line is acting as a checkpoint where those cells might move into a phase called G0. The cells are just resting. They're going to keep doing their normal life processes, but they're not working towards undergoing mitosis. Okay. There's another checkpoint that happens in G2, right before the cell would undergo mitosis, and this is a place to actually check the DNA and make repairs. So failure of those checkpoints to be effective could in fact lead to cancer, and that's what we see over here, cells not entering that G0 phase, and then also places where that mutation might actually interrupt the ability to repair the defective gene. So those proto-oncogenes can mutate into what are called oncogenes, cancer genes, and that would cause the cells not to be going to rest and just kind of continue pushing for mitosis, division, division, division. But that's not enough to cause cancer. You also need mutations in what are called tumor suppressor genes. These are the genes that would put the brakes on cell division, right? And say, maybe at this checkpoint, wait, your DNA doesn't look right. We shouldn't undergo mitosis. And so you need mutations in those tumor suppressor genes in order for the cell to kind of override that checkpoint and keep moving towards mitosis. The way I think about it, the proto-oncogenes are like the gas pedal, right? If that gene is working, you can adjust your speed. When it mutates and becomes an oncogene, it's like the gas pedal is stuck and the cell is just going to keep dividing. The tumor suppressor gene is like the brakes, right? And it should be functional. It should be able to stop you when it wants to. If you have a mutation in your oncogenes and the gas pedal is stuck on, and you have a mutation in the tumor suppressor gene, so the brakes not working, that's when cells start dividing out of control and this runaway growth, this neoplasm or cancer develops. So I hope that helps a little bit as you get started in studying cancer.